Then. Okay, hello everyone. We are continuing a meeting actually from yesterday about the future of arrays and related objects in Wolfram language. And yesterday we had talked a whole bunch about data containers or scaffolded arrays or possibly extensions to data set that are ways of efficiently storing structured collections of data. So just to define what we're talking about there, again, I think we're primarily looking at rectangular-ish arrays, possibly with missings in. Do we agree?
Yes. I think it's lists and associations with missings, and I'm still hoping we can handle ruggedness because it's going to be very important for our data set.
Okay, all right. So let's just summarize what the objectives here. Yes.
And maybe another point. At least last time, I think that the idea was sort of that there'd be different sub-implementations of special cases, which would have their own heads, right. And then there'd be a grand kind of unified head, which would basically pick an implementation, and that's the one that would support lots of stuff. But the individual smaller heads wouldn't be so flexible.
Okay, that's a sensible idea. All right, so look, objectives. Large, rectangular-ish data stored, so typically stored in nested associations and lists. Okay, so then we want to be able to do then subcases for different, storage, etc. mechanisms. So the subcases that we know, so one subcase there, e.g., cases that work in relational databases. Is that right? Is that right?
Yes.
That is the two-level case, right? And then we have, or
by that you mean basically column-based arrays.
Yes, i.e.
Which I think is a little different from relational databases, but.
Well, okay, row plus column arrays. Now, okay, so then the data can contain remote assets. I don't know whether that's something that would, in other words, that's the case where we're dealing with remote, potentially out of core assets that are mostly handled as single blobs, like a giant image, for example. Does that make sense? I mean, that's a slightly different mechanism, something that might be useful in general.
I mean, isn't it the case that the data has some uniformity, like going down a column, everything is a date or an image, or I think that's an important point somehow.
Well, you're right. That's what I'm saying. Rectangular-ish arrays with consistent data types in a given dimension. Is that what you're basically saying?
Given index.
I think that's no, it's not in the dimension. That's
with a given index, for a given index, like if it's IJKL, the K index in a given dimension / index / direction, whatever you want to call it.
I think we know what that means. I think.
Well, if you've got a better name for it, tell me.
I'm saying this is a good name.
Okay. All right. Fine. Okay. But so now, there can be missings. And okay, so this remote assets thing, which is basically, the MongoDB story, right?
I'm not sure about what you mean by that. Like, you mean that, for example,
aren't there many? There are many potential backends, including Arrow and other things, right?
No, I know, but this is a particular. Okay, let me list this separately. Mm-hmm. I mean, this is remote assets. And so what I mean by that is, like for machine learning training, you've got 100,000 images. Okay, the 100,000 backbone is something where you can group them into, pictures of dogs, pictures of cats. You're just manipulating the backbone. Okay, each image is 50 megabytes, let's say. Okay, so but most of the computations you're doing are on the backbone. You only dip down to the 50 megabyte image occasionally. Am I making sense?
Yeah, but I think you are making it more abstracted than what it is. In the end, it's just a database of image names, and you work on the databases, and one value is the URL where the real image is.
Okay, so
in this case, the remote asset is just a link.
Yes, I understand. Okay, but let me understand this. It was my understanding that our MongoDB implementation, which is fairly extensive, right, was not the same thing. That is not something we can use for, contrast for me, what we have with MongoDB. Do you understand what I'm saying? Contrast what we can do with this with what we can do with SQL.
So the difference is that MongoDB is document-based and can be arbitrarily nested. It's on you to enforce a schema. So if you want, maybe there is a strict mode, but in general, a MongoDB document-based database can have arbitrarily nested stuff, and it doesn't have to be uniform in type.
Okay.
It can be ragged, also, it can be ragged, and it's not tables.
Okay, all right, fine.
Like and then there is another big difference in that for SQL we have a full-fledged compiler from the high-level Wolfram language, while for MongoDB it has its own language which is pretty low level, and we don't have any kind of compilation step from higher level.
Okay.
It's so JavaScript, isn't it?
Who knows what it is? It's not.
It's JSON formed in a certain way.
That's the format. Anyway,
okay, so let's look then at, this is that we have a list here of, this is where we talked about remote asset arrays. So we've also got,
Sorry, one of the things we talked about is, all the little subheads will need to implement some sort of, basic API, but we haven't specified what that API is.
I know, we're going to get to that. Okay, let's make a list first of all of possible backends. Okay, so one is in-memory expressions. Okay, another would be, I'm just making a general list, cloud expression might be a backend. Do we agree or do we not agree?
Well, I haven't seen the new cloud expression. The old cloud expression, I don't think was really useful for much of anything.
Right. The new cloud expression is a fine thing that does what it does. Okay, it actually does it properly.
So more than backend, you mean like the place where the data lives?
I guess I mean that as well. But let's keep going because we've
there's the place and there's the format, right? There's
right.
There are also
there's also
so
the structure.
Places. Okay, so hold on. Places and formats.
And also maybe there's what the front end structure looks like versus the back end, right? There might be things that have a similar, they're both lists of associations, but they have different implementations.
Yeah. Okay. So then it's the next. Okay. So we've got really a table of information here. We've got where is it? What is its native format? What is its expression like? Its expression version. Is expression
serialization.
Format. Yeah, expression format. Plus serialization. Okay, so what we've got here.
Well, one other thing that's come up, and I think that so this is by far from the last of these storage systems that we're going to be designing, is that a lot of operations have moved closer to data. So what used to be like a pure storage system with some easy lookup is storage plus computations. So
Yeah, yeah, right. I know, I understand. So that means that's why we're doing, our Postgres database that geo lookups is being done on the database, not in the language, for example.
Right. For example.
Right. So I agree that okay. So and our basic strategy, our strategy is typically make a compiler from language level queries, from WL queries to native queries, so that these can be done closer to the data. Is that right?
Yes, I think that's a very important point.
Okay, so let's make a list then of general. Okay, well let's general technologies. Let's start off with that. Okay. Okay, so we've got we've got sort of the in memory. We've got the we've got cloud expression, which is otherwise known as, I don't know what that technology actually, okay, but I'm sorry.
When you say that, you mean our cloud?
Yes, I mean our cloud. So I mean SQL.
Because we could, we should use other clouds too.
Well, we do. That's exactly what external storage is doing.
Yeah.
Okay, but external storage, so here's a piece we don't have. External storage is just buckets. It's just like storing expressions, right? Cloud expression allows us to, here we can do operations on the expression in the cloud without going into memory. See what I'm saying?
It's a Wolfram language that's local there. In other system, there might be another local language.
Indeed.
That's not as general.
Yeah, right. That's exactly what happens in SQL.
Different storage systems, if you look at AWS offering, they have a variety of storage systems. And I swear that they introduce another one every year.
Well, okay. So we support some of these in external storage.
Okay.
Right? That's what external storage does. And external storage right now is supporting things like AWS, Azure, IPFS, things like this.
Right,
Okay,
but within those worlds, they're whole different. S3 is totally different from some of their other storage systems.
I understand, Roger. I understand. So my point here, okay, so what the point that you're making is we could imagine making a cloud expression for AWS.
Right.
Right. So there's a thing here.
I don't want to grasp too much. But I also don't want us to unnecessarily limit ourselves.
Okay, fine. But we're just trying to list general technologies here. So document databases.
I would add the lazy list and streaming as well.
Well, yes, you're right. I was going to add that.
Yeah.
Okay.
I mean, streaming is a thing, whether they're lazy list or not.
Yeah, files.
And that could be like CSV, it could be HDF, it could be binary.
Well, the difference really is that lazy list is kind of built on the idea of streaming and represents a list-like interface, which is lazy. But streaming on its own doesn't have to be lazy list. It can be just, chunks of things that you consume.
Okay, but hold on. Streaming is an operation.
Streaming interfaces. For audio and video, we definitely have streaming interfaces, and they use.
So streaming onto files, etc., etc. In other words, streaming is a type of interface that can be applied to a variety of external storage media. Correct? Is that correct, or is that not correct?
I think it's correct.
Yeah.
And lazy list
maybe one
is
thing
its
to
own
note.
thing. Yeah.
Well, maybe one thing to note is also just that the lazy list and streaming are maybe more natural for sort of one-dimensional data and less big rectangular data.
Mm-hmm. So let's note here, this is 1D, oops, this is, and that's a 1D story.
Well, I would just say that lazy lists in general, the chunks of things that you are lazily fetching can themselves be things like multidimensional arrays.
Okay, fine, but it's basically being processed in a single one-dimensional list.
Yes.
Right. So
that's
it's
like
1D
saying you
plus
process
remote
it
each
row at a time.
Right. Whereas SQL is 2D, in some sense. That's its native. Come on, that's its native form. You can do all kinds of standing on your head, but its native form is rows and columns.
Yeah, but the point is that basic SQL is row oriented, and so it's processed as a list of associations, whereas some of the SQL like things that are for data science are columnar, and so they're processed in the other.
Doesn't matter. Basically, we're talking about rows and columns, which is different from what we're talking about for
I think Leonid can do a list of associations.
Yes, absolutely.
I'm sure it can, but it's not doing operations that are columnar operations on those things, is it?
Actually, Stephen, I beg to differ here, because I think lazy list is more like an interface, and it basically compiles the queries down to what the constituents are. So a lazy list could as well operate in principle on databases and columnar structures.
Okay.
There's nothing to prevent it.
All right. Then you're just taking the same name to mean something different. What I'm talking about here is something which operates like this giant snake that has this bulge of operation somewhere moving down the snake. That's what the native thing that I'm understanding your stuff does is. There's a different issue and a different story, which is compiling down. I mean, if we're listing other things here, we've got things like Spark and Hadoop and so on, right? Which are essentially distributed database technologies where we're moving computation down to the database, to the data nodes, right? So, and we also, in that same thing, we've got the Arrow stuff, right?
Okay.
Yes, but Stephen, I think what I wanted to say was that lazy list is more like a list-like interface over anything that can be represented as a list, not necessarily.
I know. I understand that. That's not what we're trying. It's basically a one-dimensional thing. That's the thing we're describing here. Yes, you can put other dimensions as the elements of that one-dimensional thing, but let's not confuse ourselves any more than we need to be confused. Okay, so let's keep going here. Right. What other general technologies?
Data bins.
Yeah, that's a good idea. That's a good one.
And then there's our own sort of structured expression things like time series. I mean, those are expressions, that's a good point. But that would be obviously.
Yep, that's a good point. And we've also got databases of that type.
Temporal data.
Well, it sort of seems like stuff like time series, we want to be backed with stuff like this, right?
Yes, that's right.
We might have
same
a time
quantity arrays,
and we want to operate on it with these tools.
Okay, well, so there's also, what about the geodata? What about our back-end geodata, which is in things like Postgres and so on, right?
Yeah, that's ultimately, again, SQL.
Well, yes, it is, but it has its own special features, I think. Okay, we've also got Sparkle.
Yeah, and that's what I was going to say. In general, graph databases, triple stores.
Yeah, plus triple stores.
I mean, the backend is triple stores. Sparkle is just a query language. But...
I know. Okay, all right. So now we've got kind of places here, and we've got, in memory, we've got files, in local files, we've got cloud files, we've got cloud expression, which is a little different from cloud files. We've got which we don't yet have, but we will have, cloud/local databases, light were in-memory databases or in-file databases, that SQLite and so on. Is that right?
I'd say in process, because they can. I think they're embeddable. That's the main distinguishing feature for them.
In-file/in process, but they're stored in files.
Not necessarily. SQLite can be also stored in memory.
Well, it's serialized to a file, is it not?
Yes, optionally, but you can also say when you create an SQLite session that you want it all in memory.
Okay, but why would we care then? Why do we need that? We don't care about that. Why do we?
Well,
why is that relevant?
It might be relevant because certain operations, even we might choose at some point to store things in memory, but make use of some fast operations that SQLite provides.
I don't believe in it. I think we've got those operations already for things that are in memory. I think it's more relevant when we have, a terabyte-sized database and a file.
Well, one example would be indexes for columns. We don't have anything like that.
Okay, but we're going to. That's the whole point of this discussion, right? So take that one off the table because it's not interesting. We're going to have that, right? So let's not confuse ourselves.
But Steven, I think this is like maybe SQLite is not the thing we're going to use, but probably Arrow is
whatever.
Faster.
Okay, but we don't need this as a separate place where we're storing things. Okay, that's an implementation detail of what we're doing.
Wait a second, Steven. I think there is an important distinction between in the kernel's memory and in another process's memory.
There is. Yes, there is. Right. So what are we talking about here? We're talking about, we're not talking about this. We're talking about local databases using their own.
Yeah, but between
files
maybe
plus
between
memory
and local files, you need to add the memory of another process.
That's what I mean, using their own files and memory, right?
Okay.
Because by the time they're inside our kernel memory, they're just part of our system, and we don't need to discuss them as something separate, right? That's the in-memory case. That's what, when I say in memory, I mean in WL kernel memory, right? Make sense? Yes? Do you understand, Carlo?
Yeah, I agree.
Okay. Okay, what other places? So then clearly we have remote SQL databases that are just sitting out there, right? That are separately managed, whose management has nothing to do with us. Am I making sense? Hey, come on, say, please, guys.
Yes,
you got to actually say things, okay?
Yeah.
Okay. All right. So
here's another mode, and that's whether things are, read-only or updatable or deletable. So not all of these things you can delete or update.
Right.
Right.
I
think that's important.
Read only versus.
Call it CRUD.
Right.
Create, read, update, delete.
Yeah, I know. Versus read write.
Wait. Yeah. Right. Good.
Okay. So.
And that makes a difference as to what operations.
Okay. So we didn't mention here our whole entity store mechanism, did we?
It should. It fits here.
No, right. So come on, guys, stay awake.
You haven't named all of these things.
What's the difference? What's the difference between an entity store and in-memory? Like that is an Oh yeah, right. The interface is sorry.
Okay. All right. So again. Okay, and obviously, data set is the. I mean, again, this is a bit of a muddle. What should be where here? But okay, so where do we go? What we were talking about before was the difference between MongoDB and. So again, I don't know why we're listing these technologies. Okay, so document databases like MongoDB.
Right? Steven, I think one of the reasons why we have such a long list here is that we are mixing together things which should fall into at least two different categories, like interfaces over things and things which are kind of drivers to certain technologies.
Okay, fine. Okay, so what I'm going to expect for the next one of these meetings is that somebody else will try and make these lists in a more systematic way. Fair? Scott, can you make sure that that happens?
Yep, I'll work with the guys to try to come up with the lists.
Okay, so now roughly what we're going to be doing here. Okay, so the question is, what does the overall interface to this look like? So let's imagine that the overall thing might be data container, but there are subcases that might be, that might be as small as method options or as big as their own heads, so to speak. Does that make sense? So can we start making a list?
So, right. So I want to, getting back to the API question.
Mm-hmm.
So when we were talking about, scaffolded arrays, then, I think what people think of, or the operations people think of when they hear array, are
extract parts,
transposition.
Well, I don't agree with transposition at all. I don't agree. I think that's okay. So look, the basic API, extract parts, possibly write parts. So for example, let's look at cloud expression. What API does it expose? Do you understand what I'm saying?
Stephen, yeah, I think I understand what you're saying, but I think there are like at least two big families that have completely different APIs here, and the rectangular-ish ones and the hierarchical ones.
Right. Anything you call a rectangular array, I think people would expect, extracting parts.
Wait, remember what we said at the beginning? What are we talking about here? We're talking about rectangular-ish objects, right? Remember that? Large rectangular-ish data. That's what we're talking about here. But we're not talking about something different.
Cloud expression and Mongo are hierarchical rather than rectangular.
Okay, so are they a completely separate discussion?
You can use Mongo in a rectangular way. Like everybody that is using it in JavaScript is actually forcing a schema on Mongo. So it can be used that way. It's not an issue.
It can, but it doesn't really necessarily force it.
Carlo, we have got to stay organized in this conversation, right? Are we talking about rectangular-ish data, or are we talking about something completely different? So far as I understood, what we're talking about here is rectangular-ish data. That's the only thing we're talking about.
I agree, but I'm
okay,
just saying
so then we've got different implementation methods. If we think MongoDB is irrelevant to rectangular-ish data, so be it. I don't think it is.
Anyway, we can just drop it here if we don't need it later.
Right? That's what we're talking about.
When you say rectangular-ish, is that necessarily rank 2? Presumably
no,
not.
Absolutely not. Absolutely not. Any rank.
But for the most of those that you listed here, they limit to rank 2.
I don't care. We've been through this. How many times do we have to go through the same thing? I don't care. Do you understand what I'm saying? Every time we're saying the same thing, right? Certain backends will be suitable for things of rank 2. Other ones will be suitable for higher rank. Sometimes the rank 2 thing can have remote assets hanging off those elements at rank 2 that are higher rank objects. Does that make sense? So let's cut out the conversation. We don't need to have that conversation.
Stephen, but if you open Cloud Expression, which doesn't enforce rectangularity in any sort of form, then we're looking at a completely different API.
Nonsense. Do you understand what I'm saying? We are talking here about large rectangular-ish data. Okay, so what I'm saying is Cloud Expression is an example of a place where you can implement large rectangular-ish data. Cloud Expression does other things as well, but they are not relevant to our discussion.
But if you look at the list of functions it supports, these have nothing to do with rectangular-ish data. These just have to do with expressions. At best, append to makes it list-like.
Yeah, fine.
But everything
fine.
else here is irrelevant. I mean,
okay, but fine. But then this is not what's mostly going to be. Okay, the basic API. So this is the.
So I think so. When I hear rectangular-ish data, I mean, with the, I would say transpose is perhaps a bit of an edge case, but certainly if I hear array, I think of transpose.
Okay, but that's not what we're mostly dealing with here. We're mostly dealing with operations.
Let me finish. Stephen, let me finish, please. There's part extraction, obviously, and there's mapping at a particular depth.
Yes, then there's selecting, and there's doing all those kinds of things.
And I think appending, prepending, adding to is obviously another one, really important.
Yes.
Well, I think the key question is what does the ish mean? I mean, how rectangular does it need to be?
Well, that's what we've been talking about. Can I say it again? Okay. What I mean by that is that, okay, first point is it fundamentally has a series of indices. Am I making sense? So it isn't the case. For example, a graph is not an example of a rectangular-ish thing. Its elements cannot usefully be indexed. And yes, there are special cases. I'm not interested in grid graphs, right? In general, there are things where there is a notion of indices in a given dimension, where that index is going to range over many values, and where in some sense, there is an outer product of elements corresponding to different levels. Does that make sense to people?
For example, generalized data set is not rectangular.
So I would define this as something that admits some sort of rectangular hull without many holes.
Yeah, that's right. That's what I mean by this. And so with respect to what Christopher is saying, I think that yes, a completely general data set with different creatures hanging in different places is not rectangular-ish. That is correct. In other words, a data set where one piece of it has a giant association of associations hanging off it, and at the same level in another part of the data set is a list of lists. That is not rectangular-ish.
No, but there's even other things that are not quite rectangular. Like if you have, so suppose that it's a list of associations, but then within the associations, they have two keys, and under one of the keys, it's a matrix, and under the other key, it's another layer of associations, and it keeps going. That's hierarchical.
Yeah, no, that's
data,
what I was saying.
Right?
That was the example I was giving.
Right.
That is not rectangular-ish.
But it does have a consistent kind of schema, but it's not rectangular. I'm just making that clear.
Well, wait a minute. What do you mean it has a consistent schema? If the two elements of the association, one of them, I mean, let's be concrete. One of them is, we've got A goes to, and then it's an association here.
Okay, sure. The values of the association all have to follow the same pattern. Yes.
Yes, that's what I'm saying.
Then it's rectangular. Yes.
Right. So this is what we're talking about. Everybody agree with this? Does anybody want to have? And so what Jose has commented, that there's a rectangular hull that represents a decent fraction. So it might have some slight raggedness. And that raggedness could come in two forms. If it's lists, it's always raggedness quotes at the end. If it's associations, it could be raggedness in key space. Does that make sense?
Well, raggedness in key space should probably just mean missings.
Possibly, yes.
Yeah.
Okay, so then the rectangular hull is roughly a tight fit, but it can have some holes, but there can be missings, and there can be incorrectly linked lists. Does that make sense to people? So this is the thing we're talking about here. Yes?
Yes.
Makes sense.
Sure.
Okay. All right. So then, given this, we could store such a thing in a cloud expression. Why would we want to do that? We'd want to do that because it's a convenient way to, otherwise, we have no way to extract, the only way to extract a part of something, if it's an ordinary expression, is to read the whole thing into memory. That's the big thing we get with cloud expressions. We don't have to read it all into memory. Now, we don't, if we don't maintain rectangularity ourselves, the thing could turn into an elephant. I mean, it can be any shape, right? But that's the special case of that. Now, let's go look at some of these other technologies here. And this question of what is the API? So, the API is clearly going to need to extract parts, write parts. It's clearly going to map over parts or map over dimensions, possibly. Am I making sense?
Well, already here we have to be careful because mapping may change the types, and types is something we kind of missed in this discussion so far. When we talk about rectangular, I think the notion
good point. So is it rectangular? There's two kinds of rectangular. Is it rectangular in index space or in type space?
I think type space is even more important than index space.
So let me say something here. So I think the things to assign types to are the keys of the deepest dimension. In the case of 2 dimensions, that corresponds to columns. But if we had something of deeper dimension, we still can have types consistently at the deepest level.
Exactly. So they can vary on that last index only. That would make sense.
But then the high level ones are just aggregations of these types.
Yes.
Yes, but the point is that we cannot assign a type at the rows, at the levels, at the columns simultaneously.
Okay, so what?
Like you can't say that every element is the same type because you have columns with different types of things in them.
Right.
I see what you're saying. So
then
you're
it's just
saying
a union of the different types in the column.
Well, you can think of it that way if you want to, but the whole point is that the column, the deepest. Okay, so the basic point is for types, want as large a sort of what can we call it? As large an index span as possible to be of uniform type. So, for example, e.g., a whole list, or e.g., a whole 2D array, because both of those are worthwhile. So in the case of the transpose operation, you really want, transpose makes sense if you have an n-dimensional array, all of the same type. Transpose is pretty weird if the elements are, in other words, if all the elements of an n-dimensional array are the same type, you can transpose to your heart's content. If they are of different types, then transposing will lead to something which does not have type uniformity down a column or across a row. Is that correct?
No. If you have something that's consistent across a column, then its transpose will have consistency across a row, which is very useful in linear algebra.
Yes, but the problem is that we cannot represent it if things are at the deepest level. So this happens already in quantity array, and what happens there is that you don't touch the data, you just store the permutation you transposed.
Right.
And when you are going to extract something, you undo the permutation, but you cannot transpose the data. So we can see examples with quantity array if you want.
What do you mean you cannot transpose the data? See, I mean, right. I mean, certainly, maybe as some implementation detail, you can't transpose the data, but you can certainly, right? I can take the normal of both the original guy and the transpose guy, and I see something that's an array with either consistent units in the column or consistent units in the row. And so I don't understand why you're saying I can't transpose the data.
If we are assigning the types to the deepest level, and you transpose the deepest level to the highest level, then you have a problem in the representation. If you normalize, it's all fine, but the compact representation is not adapted anymore.
Is that just because the quantity array only lets you specify types like by column or something, right?
At the deepest level, it can be
okay,
2 levels or
the generalized
3
column. The generalized
exactly.
column, though, yeah.
Exactly.
But so when your generalized column is switched with your rows, then you can't. Yeah.
Right.
Okay.
But I still don't understand why that's a fundamental restriction and not an implementation detail of quantity array.
Okay, I'm not sure. Let's not cover that right now. Okay. And I really want to see Rob's threaded demonstration. So, but what we're seeing here, let's just define what we have to get here. We need a better list of these, backends, technologies, storage places, formats, etc. Okay. Then we need the the different levels of API, the different kinds of operations that we might do on these rectangular-ish data objects. Please don't confuse things which are general expression computations that are not relevant to rectangular-ish data. Make sense?
Yes.
Yep.
And then let's see what we want to do here. Okay, so then the goal is, as we talked about before, we've got the underlying data representation and we've got the wrapper. The wrapper is the thing that is the translation layer. Okay, so actually we've got several different concepts here. We've got the underlying data representation. Well, I mean, okay, so let's just list something for sort of architecture. We've got sort of.
Can I before you move on to architecture, can I ask something about this rectangular-ish definition?
Perhaps.
Could you
Go ahead.
generalize this so that basically indices, except the last, are generalized indices and could be strings instead of numbers?
Of course they could be. Of course they can be. That's the point of associations.
Yeah, so
of course.
So at that point, basically, you could always say.
You cannot just have random gunk in these higher level indices.
I didn't say random gunk. What I'm saying is that if you have something where you have 3 dimensions and the first 2 are like first name and last name, then you
don't have a rectangular-ish array. Period. End of story. If those are, Smith, Jones, whatever, and they're completely different. In other words, the whole point is it's an outer product type idea. The I's form a collection of possible keys. The J's form a collection of possible keys. It is the overall key for an array element is based on an outer product of those key lists. Does that make sense?
Yeah, I'm just saying what I'm describing is a bit more ragged, but
I know, and I'm saying it's not included. That's not what we're going after. We're going after the case where each one of the indices has a certain set of possible values, and the possible indexing of a single element is the outer product of the sets associated with each of the individual indices. Does anybody have a problem with that definition?
It seems to me that
it's clean. It also means that you have basically a list of what those indices are or keys are in that outer product.
Yeah,
but that's the thing is that it's too
Carlo,
clean.
It's irrelevant. It's irrelevant. We don't want to do that case. We are doing the case we're describing here. We are not doing the generalization of that, because guess what? If we do the generalization of that, we cut down. I mean, why do you think we should do that generalization?
Because that's the shape that real data takes in the outside world, and that's why it's usually basically what you do is
nonsense.
Like you have more people.
Nonsense. Nonsense. It's just nonsense. You're misunderstanding what we're talking about. We're not saying that, okay, so here, the index here is first name or last name, not the actual Smith-Jones names, right? The index, the thing, maybe I'm misunderstanding something. Can anybody else help me here? I think Carlo is talking about something completely different.
Explain my idea before you say it's nonsense.
Okay, go ahead.
What I'm saying is that it is common that you have multiple keys that together form a unique thing. And so you can slice it and dice it in as many ways as you want, but in general, it's still stored as a bidimensional thing. So they form a unique identifier. But you can take all the people who have last name Wolfram or all the people who have first name Stephen. They're not unique separately.
What are you talking about? Why is that relevant to this data representation?
Because this is what people store data like.
Anybody else wanted to jump in and understand what's going on here? I don't understand this.
I don't understand what Carlo is saying, but my impression is that whenever you have a list of keys, you can declare an index that runs over those keys.
Exactly.
And then you are in this framework again. It's just one of these indices.
Yeah, but you have no requirement that if there is
Carlo,
that there is a Stephen Barbieri somewhere or
Carlo,
those are missings.
Are you talking about this sort of the value basically?
Yeah, I think he is.
Are you
I'm not talking about the values. I'm talking about the keys. What I'm saying is that multiple indices, it doesn't really matter that they're full. It's a sparse representation of the same thing. It's like a sparse association, ends up being bidimensional anyway. It's more general. It looks more like real.
Okay, I think this is not what we're doing.
Like
okay, so let me give a concrete example here. What you're saying is X arrow, list A, wait a minute, 1B2 here, okay? Now you're saying then in the world of rectangularity, we would say Y goes to the same kind of thing, right? That's what we think we mean by basic rectangularity. What you're saying is, instead here, let's call this P and Q, for example, right? That's the case you're talking about, correct, Carlo?
Yes, there is an operation where you basically can flatten the indices and have XA.
I understand that. I understand it. Let's get straight what you're talking about. Okay, the difference between what we were saying before, which is to say it is an outer product of index sets. This is the case where it's an outer product of index sets. Yes? Does that make sense?
Yeah.
Mm-hmm.
Okay, this is the case where it's not an outer product of index sets. Okay, so in the previous definition of rectangularity, we are excluding cases like this. Right? Yes? Do you understand? Yes? Okay, now you are objecting to excluding cases like this. Is that right?
Yeah.
Okay, so let's understand that. So in a strict definition of rectangularity, this is excluded. Okay.
So I would say we can have the possibility of a union of keys and then have some heuristic parameter. It's a bit like a sparseness. We allow some such percentage of sparseness.
Right. So now let's take the intermediate case where we also have A goes to 7 here, and where we might say, well, we can just take the union of all the keys. Right? But now Carlo is making a different point, I believe, which is to say that, is there an operation we have for doing this that turns this into XA, XB, YPP, YQQ, right? As keys.
Yeah.
Okay, so it's one-dimensionalizing this thing. Okay, big deal. I mean, sure, we can certainly do that, but I don't think that's critical to what we're talking about. What we're talking about is the native data structure that we're dealing with here is a rectangular-ish array. And you're saying we can transform this thing, which is not a rectangular-ish array, to a one-dimensional, quotes, rectangular-ish array by essentially compressing across there's 2 dimensions of keys. Is that correct?
My general point was that any sparse-ish multidimensional thing can be represented as a rectangular 2-dimensional thing by unioning the keys. And so
why is it 2-dimensional? Why is that a convenient thing to do? I mean, what Jose was saying is there's a sort of a heuristic of down to what, if what we have efficiently implemented is rectangular-ish array operations, then for sure, things which are not rectangular-ish, we might want to, by virtue of the wrapper, turn into something rectangular-ish. In other words, that to me, that's a responsibility of the wrapper to figure out how, given the native underlying representation, which we are agreeing is rectangular-ish, how do we translate the actual form into that format? So similarly, if we had a quantity array and we've transposed a quantity array so that random elements are in feet or seconds, we don't really have a good situation. Our wrapper has to contain tons of information about how element 17 is in feet, element 18 is in seconds. so to speak. That is not a good rectangularish object.
Yeah, but that's why I was saying like the example you're showing here is basically each of those is just a single row, and then you repeat that multiple times. What I'm saying is that, like, suppose you have first name and last name. Each person then, which is identified by first and last name, can have different ages, can have one age, can have an address, can have all sorts of things.
Yes.
Those are uniform in type, but they're indexed by two things: name and first name.
Whatever.
And last name.
I don't see why that's a big deal. I don't understand.
What I'm trying to demonstrate is that the most general case is still the one that is two-dimensional.
Come on. No, it's not.
Be flattened.
Yes, of course it can, but that's not relevant. We're not going to represent everything in 2 dimensions. Yes, you could in principle represent everything in a database, in an SQL database with just one table, no foreign keys, nothing, just one table. You've squashed it into that. But guess what? Many operations will be unbelievably inefficient in that form. So we're not interested in that.
And I would say, what's special about 2 dimensions? Why not compress everything into 1 dimension at that point?
Yeah, it just doesn't make any sense. It's just okay. So let's go back to our definitions. We are imagining there are rectangularish things, and no, they will not all fit in 2 dimensions. If we insist that we're going to use an SQL database, then we will have to squash them into 2 dimensions at the cost of great decrease in efficiency for certain kinds of objects. But otherwise, our general definition is arbitrary dimensional rectangularish things, where there is translation there's essentially an address translation layer, which is the wrapper. It's more than just address translation. It's also element wrapping with things like quantities and so on. Does that make sense to people?
Yep.
And that wrapper might also take care of taking dates, let's say, which might be stored in some native single number format, and it turns them into data objects and things like this.
Except, Stephen, it might be what you are calling a wrapper might be kind of a scheme with certain type, transforms. So it might be not necessarily for a single element. It might be some kind of metadata that instructs how you convert the types.
Oh, I agree. No, that's what I would imagine. The whole point of the wrapper is something which is a bulk description of what to do with lots of elements. If the wrapper has to individually address every element, the wrapper is the data, and you've lost the game.
Exactly.
Right. So, but the point, and that's why, for example, if there is, that's what Jose's definition of slight deviations from rectangularity, that is something, the wrapper can handle, 10 missings in 1 million data elements. By the time it's 750,000 missings, then it's not a good representation, because then you've got 750,000 objects in the wrapper in the address translation table effectively. Does that make sense to people? I mean, so I think we've got an outline of what we're trying to do here. That is, and so one of the other objectives will be to figure out what are the operations, what are the native operations that we can expect might be doable on this rectangularish array. Okay, and those will include the operations that we have for relational database type operations, like the sorted entity classes of this world and so on, right, guys?
Yeah.
Okay, so let's make a list of all of those. And then for some types of backends, some of those will be difficult to support. For example, all the ones associated with writing will be unsupportable in the case where the backend is read-only. Does that make sense?
That makes sense. There's another thing we haven't quite thought about, and that is whether it mutates, whether these things are mutable or not. Like expressions are not, in most senses, mutable. So that's another way of thinking about the operations.
Yes, that's a good point. That is a good point. That's another.
Maybe we should have names, consistent names for mutating, like we have append to, but maybe we should see, like map. We could have map in, which is like mutating, and map, which is not mutating.
Well, map at is kind of map in.
No. Map in would like mutate and map would not.
I got it. I got it. So, but I mean, it's a little bit confusing because the second argument here. So that's the
or map to. I don't know. Or select. You see, you could have select that would mutate or not mutate.
Right.
Of course, if you just have fold and things like that, it's not a problem.
What do you mean?
Well, fold doesn't mutate. Fold just does, iterates across the thing, and yeah.
Right. I see. Fold is returning is doing the reduce as opposed to the map, so to speak. Right. You don't. The case where you are interested in mutation is where you are going to leave the basic structure the same.
Yeah,
right?
You're modifying the input.
Right. Mutation is relevant. No, I understand that, Tom,
Yeah.
but there's a different point. Mutation is relevant and worthwhile, i.e. worthwhile, when it sprinkles operations across an existing structure. In other words, e.g., it's useful for map. It's not useful for fold, because fold is just taking everything.
Yeah.
Right.
Yeah. Now the function that's being folded might mutate, but yeah, what you're saying is true. Yes.
Right, but so maybe there's a different operation, which is a general mutation operation, in which what you're doing, I think the mutation is a headdress thing, right? So what it is something like, okay, so I'm going to claim it's something like this: mutate of map of, okay, so we've got expa here, which is essentially the handle to expa, and we've got, okay, I'm going to claim it's something like this, because map has a curried form, so it can just do that. Right, there's a general mutate operation that says this thing here, this is essentially, I mean, this is equivalent to expa equals map f onto expa, right? And I'm saying I think there might be a way of factoring that so that you have a mutation operation like this, which takes as one argument the function that is the mutator.
I would expect that mutation is particularly useful when you have to change only a few parts of the whole expression. And therefore,
yes,
the add functions like replace.
It's also just part of the culture of the technology that you're working with.
Okay, but that's okay, fine. But do you understand what I'm saying? If we want to have a top-level interface, we do not want to have 300 functions that are mutation variants of functions we already have. Am I making sense?
Yes.
So, right now we have a limited number of functions that show basically assignments and things like append to and so on, which are mutation-oriented functions. And most of our functions, like map@, doesn't have a mutation form.
By the way, isn't that thing you wrote with mutate identical to the, what is it, / equals?
Oh, it might.
Your cursor is on right now.
Right, I was just going to bring that up.
What is okay, / equals is this, right?
Apply to.
So that's, you say it's equivalent to this.
The fact it's also called apply to is notable, maybe.
Yes, that is notable. So you're saying like this, a minute. Oh no, I see. So what I need to say is expa equals ABC, and then I say this, and then I say what's expa, and it's that. Beautiful.
Right, but I guess,
so this is really,
unless the precedence is, I mean, chaining these is pretty painful. I mean, maybe unless the precedence is sort of strange, but I mean, maybe I think it would be more natural if there was like a headdress or something than expecting people to really write this when their data is like, yeah. Like if you're dealing with a database where you have to do mutable operations or something like that, you can't map and copy, then I think asking people to write it like this is kind of nuts.
All right, let's have a very quick, I'm late for something else, but let's have a very quick demo of the threading stuff. Rob, are you ready for that?
Well, Jose has a notebook.
Okay, are you going to, oh, you say I can do it, because I'm.
Yeah, you should just be able to do it.
Okay.
Exactly, in the X kernel.
Okay, I'm in the X kernel. Oh, that's really old.
Super old. Yeah, you need.
Oh, for goodness sake. Well, so somebody else needs to. Oh, this is wrong. Could somebody let Roger know? I don't know why this is not updated.
Jose, maybe you could just show your notebook, which was got that quite nice.
I'll let Roger know.
I can try this one instead. Let me just try, see if I can run it myself.
No, it's still saying 13.0, and right. I think probably forgot to update the prototype to grab 13.1 instead of 13.0.
Bad. Okay. All right. So somebody else who would like to demo?
I can do it.
Yeah, that'd be great, Jose.
Okay.
Okay. So let me check that they have, yes. So this is how it works. We have this array. And if we do threaded here, then, sorry, to remove this stuff. And then you see we get.
That's lovely. Oh, it's the broadcasting. Nice.
Yep. And this works also for cases of deeper dimension. So something like this.
Let me look at this. Let me understand this. So threaded by default is looking at the other thing with the plus operator, and it's going to the deepest level. So if you take that first expression and you say plus threaded of CD.
Of here.
No, in other words, a ternary plus.
Oh, I see.
So add in a plus threaded of CD.
Yep.
Magnificent.
Yeah. It looks really at the deepest level of the unthreaded part. I mean,
okay. So now, just for fun, could you say 5, 6, 7 in there? So that's going to error out, right? Is that correct?
Exactly.
Okay. All right. Okay. Fine. Okay, but put back, remove the 7 again, just so we have something that works. Okay. Okay, that's wonderful.
Out of curiosity, does it also? I don't know if we ever actually fully designed these, but the second arguments of threaded, or the second and third, I think it was.
It does not do that, Christopher. I have thought about that. I think I know possibly how to do it, but I'm doing some other stuff. I took a break from it to let it jail for a bit, but I think it's might be possible to do that.
But so just to review what that is, right now we've got 2 cases. If you have the naked plus with the stability, it will go on level 1. It will try and thread at level 1. This will try and thread at the deepest level. The alternative is to thread at level n. Correct?
Correct.
Which is.
Sorry, Jose, can you try adding plus EFG at the end? Right, so we have both threaded and not threaded.
Yes, that works as well.
That's lovely. That's really nice. Okay, so just to understand here, the operation that this is equivalent to in terms of maps and so on, there is some mappy version of this that for level n is the there's some theorem that says this is equal to something involving map. Is that true?
So I would say this is a thread at a particular level, and I was defending that we should have map thread work with negative levels, and then it would be like,
I see, then that's just like
-1.
Yeah,
right, that makes sense.
Yeah, so that's the thing I was defending here.
Okay.
I mean, isn't threading always equivalent to building an array, filling it out to an array of the right shape, and then adding them as fully formed arrays? It's always doable like that.
I think that was like Etienne's prototype worked like that, but I thought the point of this is that it could be way more efficient.
No. I'm just saying if you're gonna as an explanatory model.
Oh yeah.
Yep.
Say that again, Roger.
You can always that threaded AB. You can build a matrix.
Oh, I see.
But
it's
with
AB,
A's and B's.
AB.
Yeah, repeated.
It's the same shape.
Yes.
Right.
And then it's just normal matrix addition. There's nothing funky. But I think it's a good explanatory model to do.
Right. So in other words, the threaded is the equivalent of repeating the appropriate number of times to fill it in to be the same shape as the first thing.
Yes.
Yes,
Okay.
that is the discussion of replication we had with Etienne.
This is lovely.
Or maybe if you want to look at it with map, the EFG is map plus with at level 1, and the threaded AB is map plus at level 2.
Yes. Okay, let's see some more here. What did you have about arrays and associated? Okay, so this next one here is saying we're taking that, and each one of those is being. Could you write out could you just do in that initial?
Yes.
What the heck is the array reshape? Just make it. Just do the command shift whatever to make the array reshape in place there, just so we see what's actually operating on.
Sorry, matrix form. So this is an array of these dimensions, 4, 3, 2. And the point that we want to make here is that this has to have the dimensions at the deepest levels, but it can be several of them.
Right. So just for my benefit, could you do the same thing, but instead of that, do threaded, just threaded AB? Right. Make a copy of that. Make it. Yeah.
Yeah. Just
okay. So then that's going to just that's going to replicate itself across all of those things and then do that. Magnificent.
And so I guess the case, the one case that isn't handled yet is the threaded of ABC, right? That's
right.
Work,
but
right?
at the higher level, which would then do. Is it clear what that does? I think it is clear what that does. Is it clear what that does?
I don't think, I mean, here that we have unique dimensions maybe, but right, what if there were multiple 3s in there?
Exactly. Right. I mean, I
no.
That can't.
No. It's the dimension 2. I mean, it's like
it's dimension. It's level 2 that this is operating on.
Yeah.
The 3 is irrelevant. But the question is it clear what at level? Okay, if we did the plus, yeah, I see. It is clear what to do. It is clear. So then what would happen is some of these would plus C, some of them would plus A, B, C, going across that top row there. It would be, the first thing would be 1 plus A, 2 plus A, 3 plus B, 4 plus B, 5 plus C, 6 plus C. Is that correct?
Yeah.
Does that actually work?
Not yet.
I'm lost, but are you discussing whether this should end up adding here?
No, absolutely not.
Okay.
Nobody thinks it should. Exactly. Nobody thinks it should. What we're thinking, so make a copy of that input line.
Right, there's some second argument you'd
right. So now type threaded ABC.
Yeah, -2 for the second argument. Then
threaded ABC, comma either -2 or +2 in this case.
Yes.
I see. Yes. So this is the idea of I was saying here of map threading at the level -2, and then it would do what you are expecting.
Right, but we could also say level 2 here, correct? In this particular case, it's just saying the second index or the index 2 from the end.
Right. So then where that matters is with ruggedness precisely, because if we have something like 1, 2, let's say something like this, and then 2, 3.
Exactly. The -2 and the +2 will not be in the same place.
Exactly. If we generalize to ruggedness, then we have a different choice here.
Well, let's do that with the threaded there. So let's see what that does.
I think this is failing right now.
Okay. But what do you think that should do? Okay, so, I don't think there's a problem that fails right now.
Right.
I mean, in other words, it could. I really don't think it's a problem. Just like listability won't work if it isn't, if the dimensions don't conform.
Yes. So I think the right thing to do here is to have a way of specifying from outside, but differentiating positive and negative levels, and then you know from which side to count.
Yes. Well, I mean, so you're saying threaded might actually need a more complicated specification that says pick either -2 or +2 or whatever it might be. I see. So the only thing that's well defined is it's a uniform dimensional object on the left, and the threaded. I think it's well defined. If it's a uniform dimensional object, just having the ± level on the threaded is well defined, right? The second case this case, the 432 case that you've got here, then it's well defined. It's only if that thing is ragged, if that first argument is ragged, there's a problem, I think.
Yes, but I think what I was discussing is whether we should have here positive or negative signs. I think they should mean different things.
They do mean different things. Yes, they should mean different things, but they mean different things with respect to the 4, 3, 2 indices. Like -1 would be the
I see what you mean.
And +1 would be the top level, but it doesn't, if there's raggedness, I don't know whether we can define that.
I see what you mean. Yes.
I wouldn't do the raggedness initially. I would just punt, as you have done here, and maybe we can have some future meaning for it, but I don't think it's the most important thing right now.
This rectangular thing with the full thing is super useful for data science already. This will cover a lot of cases.
Yeah, I know.
Without raggedness.
It's actually not as inefficient as I thought now.
That's nice to hear.
Well, good.
I mean, it unpacks to one level if you say add a big matrix to a packed array with threaded. But
I'm going to count on you to keep it as packed as possible.
Yeah,
but let's see, Jose, did you have?
Yeah, Stephen, but that's okay.
Okay,
and I assume this works with any listable function, so you could have used arctan instead of plus there.
Yes. In fact, you can define what I did to demonstrate is I set up a function. I gave it the attribute listable, and you can see where the indexes are going really easily there.
Yes. Yeah.
Yeah. Okay. Out of curiosity, just to the pushing it further, like, does it? What about like associations?
Well,
you have like a list of associations running over it.
That Jose and I are thinking about, and that goes back to the scaffolding stuff.
Okay, can you show us roughly what you have in mind here? So right now with an association, if I say +3 to an association, it will listably thread down to the elements of the association, correct?
I don't think so. I don't think listability.
Try it.
Yeah, I think it does.
I think it does too. Try it. Just type an association. Some trivial. Okay. So now say outside the whole thing, just say +7 or something.
Or X.
Yeah, it works fine.
Okay.
And what
I remember there is some subtlety about listable functions and associations, but
yeah,
maybe it's when you have a combination of lists and associations that we.
Well, that I'm sure is hopeless.
Well, no, I think it gets more complicated when you start adding, when the 7 is itself an association and you're trying to line up the keys of the.
But it does work. It does work, and I think it assumes that. Just try that with A and C as the second association.
I see.
It does work. It iterates through the associations to check them for compatibility.
Okay, now try this.
Right.
But if it was A and B, then I think it would work.
Right.
Even if the left one was, and maybe if you put the left one in list, just to make it even harder, like the left association in list. I mean.
Oh, I see.
Yeah. Sure. Right.
What is that doing?
It's really? The point being, if you had a big list of it, it's the same as with lists. It's the same behavior as with lists.
Right. It first threaded over the list, then it threaded over the association.
Oh, I see. I get it.
Yeah.
Right, but the associations have to be alignable, so to speak.
Yeah.
Yes, and I bet have to be identical. And like I try if you reverse the order of one of those associations, it'll probably break. Right. Yeah.
Yeah.
Okay. This is quite lovely.
Oh, okay. I looked it up. The issue I was thinking of, there was a question of when you have a list and association, who wins? And the answer is the list wins. But
I see. Which is threaded over first? Yeah.
Mm-hmm.
This is great. I mean, what other bells and whistles? And we should wrap this meeting in a moment. What other bells and whistles are we imagining for threaded?
Well, possibly some non-rectangularity, and possibly this second argument.
I think the second argument is important and doesn't sound too hard to implement. I would not worry so much about non-rectangularity.
Okay, fine. And then the next bells and whistles are sound easy, but it's the most work, and that's making it work with packed arrays.
Yeah. Seems very important. And the name threaded, how are you feeling about the name threaded? It's not obviously horrible.
Hey, Rob, let's make it work in the compiler. Then use that for
right. Exactly, Tom. That's
yeah. But we could have threaded be a type.
I say that I think threaded is not. I agree that threaded is not terrible, but I'm not sure it conveys quite the right meaning.
It would be lovely if it was shorter.
Oh.
Okay,
to be thought about. I mean,
sorry, Stephen. One side question, and that does it. Maybe this was just in a previous meeting where I was not here. Does it make sense to have something that does the same thing but from the outside?
That's listability, isn't it?
Yeah, no, he means like a wrapper.
Like with
that's map thread.
With different threading, or where you put the plus in and you do the thing. Okay, so this map thread generalization with negative spec that Jose was talking about, basically.
I think we'll just do that.
Yeah, so I was defending that it should be this.
Right.
Okay.
What do people think of the name at depth?
I don't.
Yeah.
I don't. Yeah, I'm not into that.
Okay.
At depth, as in like it's a catfish. It's swimming on the bottom of the ocean.
Right.
Well,
It's right in the single argument form. It's at the deepest level, and then if you want to specify at what depth it's swimming, then you give it.
I understand, but I think that the case we really want to name is it's going along the bottom of the ocean.
Right, so it's a flounder or something.
Yes,
bottom feeder.
Right. Deepest.
Yeah, I think that's just utterly obscure to say deepest. Because I think what the question is, how are people thinking about this? They're thinking about it as, I mean, what we had done.
Of course, I think about it in terms of array level. So deepest makes perfect sense to me. But
I know, but you're thinking about the indices. Maybe that's from your life in general relativity. Okay. He says. But
then the level argument we said may come as well, and then that's no more deepest.
I understand. So we don't want the word deepest in there,
no.
Even though it is a good contrast with listability.
Exactly. That's where I was coming from, right?
Yeah, but the question is how people think about what they're doing. Right, I understand. But what people will think about here is, I want to add. I've got a list of vectors. I want to add something to the x coordinate and the y coordinate of each vector. And I want to do that for a list of vectors. What would you call that operation?
Well, in many languages, plus.
I know. Other languages.
So we want something that basically disables listability, because we want vector variables.
Okay, that's a separate topic, isn't it?
I think it's basically the same headdress. It just says disable it.
Okay, that's it. Okay, that's a good topic, Roger. Let's pick that up another time.
Right.
Okay, because I know you need that. You need something where you can do a plus, and where it's a list AB plus this thing which symbolically represents a vector, V plus AB, where you've got. So that's a good point. So what you've got then is, on the one hand, you've got threaded, which is saying I want to insert myself as a vector at the lowest level. On the other hand, you have V plus list AB, where you want V to say, I'm not actually, I look like I'm a bottom level object.
Well, we have just
I'm actually not.
We have sort of a very simple automatic type system in Mathematica that thinks that a symbolic variable is a scalar.
Yes, I know. So what you want something that overrides that.
Yeah.
Right. So
this one overrides listability. We want to override listability in a different way.
Right, but go ahead.
One other thing we call this in images is interleaved. That's another concept.
Well, that's a nice name.
That's a type of transposition.
Actually, Bob on our live stream suggests injected. It's not terrible. It's not terrible. We should make a note of that, please, because I think that's an interesting concept of. But what Roger is asking, V plus list AB, we should talk about that next time. What wrapper you can put around the V to say, I don't want to be caught up in listability.
Right.
Right.
I mean, it's almost like threaded 0 or something, but
it's not.
I mean, really, it's like a hold. It's like a hold listability.
Right. What we do it now, but it's really not great. Is to have inactive plus.
Yeah.
Unthreaded.
That's horrible.
It's absolutely horrible. Yeah.
Let's discuss it next time.
I know.
Okay. So we've got two branches here. We've got the threaded discussion, which I think looks to me to be completely separate from the discussion about backend, data containers. So let's break this into two separate meetings, one about threaded and one about backend data containers. And the threaded discussion probably could be pretty much merged into an ILD discussion. Up to you guys to do that. All right. Well, this has been productive. I really like this threaded thing, and so do several people on our live stream. So this is a winner, even if its name is not yet settled. I mean, I think it's got to fit into the splice, nothing, etc. family. Somehow rather similar to the splice idea.
Note that splice is called splice, not spliced.
I know. But that's because splice is a noun. As in a splice of a...
I never interpreted it as a noun.
Me neither.
I roll. We had a long discussion about this. Well, okay, fair enough. All right, okay, let's wrap this up. Thanks a lot, guys. See you later. Oh, actually, somebody's suggesting stitched. Somebody should write that down.
I've got the list of suggestions. I'll forward it to